Hello, hello, hackers. How's it going? I can see you all are joining here. The numbers are rising so fast. It's insane. Glad to see you all here and excited for the event. I'm excited too. I know that it's been a wonderful, wonderful week so far with lots of amazing stream, but this one is a super special one that we have in store for you. I know that you've been building software all week, but have you ever thought about how does it work when you're working for, let's say, a large scale software where you have to optimize it for scalability? I know, right? Lots of tough questions being answered here up in the stream, and we have our wonderful, amazing guest speaker who's going to help us learn about all of these technologies and methods where we can apply and get started with real simple. So yes, I know that you all are sharing your excitement. Just post in the message in the comment section. Tell us where you're joining in from. We'd love to hear from you. Make this as interactive as possible. If you want, just post your messages in the comment section. We would love to hear from you. And yes, without further ado, let me introduce you to who our guest speaker is. So we have Tigran here live backstage. I'm going to ask him to come up shortly, but let me give you a quick introduction about Tigran. So, Tigran is a software scalability expert with over 10 years of experience in the industry, and he's a serial entrepreneur in tech. He maintains open source projects like Allen.io, Treescale.com, and he is currently growing as CTO as a service concept in blockpulsar.com. We are so excited to welcome you. Hello, Tigran. How's it going?
Hey, it's going good.
Welcome, welcome to the show. And we're so excited about your talk here on optimized software at scale. We would love to get started, with all of this. But yes, definitely, there's a lot of excitement in the chat about this, as you can already see. So I'm going to bring up your presentation and then we can take from there. Sounds good?
Yeah, sounds perfect.
Awesome, amazing. All right, there you go.
Cool. So hi. This presentation is going to be basically an introduction into how to approach software development, keeping in mind that at some point you have to scale your services and like operate in larger scale. This is not entirely dependent on your user count. Sometimes we see even cases where handful of users just face the same problems as the large scale enterprises do. This is kind of common mistakes of software development that I want to cover with this presentation. But before we jump into the slides, I want to tell a little bit about me in very nutshell. I'm a software scalability expert and tech entrepreneur with more than 10 years of experience. As an open source projects, I've done Align.io and Treescale.com, which are still going on. And at some point, started to record also YouTube videos related to tech. So you can check that out as well. Without further ado, let's jump in straight to the specific topic that we are going to discuss. And straight from the beginning, usually the startup infrastructure or how they start with the basic project coupling. It is usually just a monolith application with some database connection and the storage. And sometimes even I really like to keep storage within the same server as well. So by no any means like this is terrible infrastructure for the long run, but in the beginning like you really don't need to overcomplicate stuff, and especially with the projects like right now like you don't know what's going to work. It's better to start with the basic tools, and pretty much all of the frameworks out of the gate support this kind of monolith infrastructure, so there is no need to complicating at the beginning. But there is some tactics that you still have to keep in mind developing these kind of applications that will gonna grow at some point. That's the hope, at least. After some time, when your project code base grows and you start to care more about not having a downtime or data loss, there comes a need of scaling the monolith backend service into multiple instances, which still of course like keeps the same ideology of having database connection and the storage itself, everything in one place. Usually, this is like one or two servers separation, nothing really fancy. And this is also going to work fine if you have a very small team and if your business doesn't have that much like business logic or like background processes that you want to run. But bear in mind that for the modern server side applications, in 99% of cases, performance is not the issue. Especially, it doesn't matter if you use like Node.js, Golang, or Python. Programming languages doesn't really make any difference, actually. In IT companies, the most valuable thing is actually developer time and infrastructure costs. And so if you keep developing on the same code base, bug will arise that will affect developer time, and server costs will arise as well, because at some point you will end up with a giant application where you will need larger servers instead of having disposable like serverless infrastructure with the microservices. But that will complicate stuff, of course, as well. So there is too many programming language benchmark works right now going on, and I've seen sometimes on Reddit telling that like Golang is better than Node.js, but in most of the cases, like current CPU performance stage is that pretty much all programming languages perform very similar on business application cases, and it really doesn't matter sometimes. That's why I really like to say that code is fast, but your network and storage input outputs are slow, especially when you work with the database and your code highly dependent on database. Your application will get slower over time when you will have more data to serve and through your services, and you have more services connected to the same database. In particular terms, the same task could be executed 100 times faster if your code will have all the data available in the RAM directly during that execution time. But of course, like it's obvious that we can't keep everything in memory using our like code memory execution. Database makes sure that everything is persistent across our services, but that of course comes with the cost of the network latency, which usually affects the most in database performance tasks, and of course the web response latencies. So this is probably the most important takeaway, that in practice, don't overthink about writing the most optimized code. Think about optimizing the amount of requests you are doing against your database. Minimizing database queries by sending least requests possible. That's the main tactic for optimizing network based applications and, in general, web servers that work with the client softwares. So I'll bring an example that happened directly with our one of our products. Back in 2021, we had the service of providing blockchain data aggregation and serving that as an API endpoint. Sounds like a very simple task. And initially, of course, without overthinking that much, we've built a very simple structure of taking data from Bitcoin node, doing some data processing, bringing that to our data structure, and then responding that to a client with the standard API endpoint. It turned okay for the beginning and everything was fine, reliable, but we were having around 200 milliseconds of response delays. And that's all because of the Bitcoin node was giving us data slower than we were expecting. And 90% of time before actually our clients getting response, that was the time we were fetching data from Bitcoin node. So our processing was fine. We don't need to optimize there. Code was running pretty fast. It was scalable. But the only thing is that we were highly dependent on that data source. And usually that's the case for other application stuff as well. When your database grows, the response times gets a bit slower and your application suffers because your services usually depend on the data that they receive from backend databases. So that's so there is where we can introduce the concept of that we call atomic services, where your code doesn't need any other external services or data to do the task or send back a response to the client. It is the ideal state, of course, and it's almost impossible to achieve that with modern business applications and web apps in general. You always have to be accessing external data source or calling other APIs to do the job. But usually it is the most efficient way to decrease amount of data or external service dependency as much as possible. Or there is a tactic of introducing a temporary cache, which essentially caches the data that it gets from database, and then reuses that after some time by invalidating that. This tactic works the best when you don't have to send back a time sensitive data and you have a large amount of requests coming to your API. Otherwise, those type of things aren't really giving you any benefits if you are in low request mode and you don't have that much data to process with. These kind of caching strategies work best if you have a background worker that constantly fetches the latest data and updates the cache, and the client facing API doesn't really care where the data comes from. With the simple caching tactic, the response time went down like 10x, and we have been able to scale our data processors only without worrying our API side. And that essentially because API itself is very simple, of course, like it doesn't do that much. It just checks authentication and then it reads the cache, which is already pre-populated data, and sends back to API. That all becomes just very simple API request and response thing immediately after having this background job processor. It also beneficial from the perspective of reliability. The worst scenario that this could happen, like in this kind of environments, is that something happens on the data source side, you lose the latest data, but you still have the old data in the Redis cache or like any other cache system that you will end up using. Your client will receive an old data, but it's still something, and usually that's enough. For example, in Facebook's and Instagram cases, if you try, for example, open an app, close, and then turn that into airplane mode and open app again, you will see your old timeline. And this is because they cache stuff on the mobile app until they fetch thing new timeline for you specifically. But in offline mode, because they don't have the kind of request capability, they still show the old timeline just to have something for you and make feel that app is usable. But of course it's not like they can't do network requests. But that kind of tactics help also to make user friendly UIs as well. So this is also important, not only from the backend perspective, but also having this kind of tactic will benefit also UI development as well. And in UI, there's also a ton of caching happening as well. For most of the IT infrastructures, I will say the key component is background processing or data pre-processing for the API request that you know for sure your user will do. For example, in Netflix, they pre-populate your account suggestions every day with a scheduled background job processing, so that when you open their application, you immediately see suggested movies instead of waiting them to load. Usually, when I'm trying to optimize an infrastructure, I look up what are the most common requests that this infrastructure does and receives from clients, and I try to connect them with the backend job execution to just pre-populate the results upfront if it's possible, so that each request will just read from the cache instead of doing everything from scratch. And that is because usually when you have a large scale infrastructure, or even like you are on a budget and you have less things in deployed in the server side, you still want to spend less money. And if you do things in a cached way, you will end up using less CPU resources or less Lambda executions if you do AWS Lambda hosting. So those kind of things also cost efficient. It's not only the response time that matters for these type of cases. So at some point, when in-memory caching was effective, most of IT companies got very obsessive. I remember those times where, specifically with like PHP applications, with using memcache, it gave too much performance boost for these kind of monolith applications, especially for WordPress ages. But another problem started to arise, which is if you abuse too much cache and it deployed to one server or like two, you start to get network congestions. And that network congestion will feel that your Redis cache actually slows down your application, but it's not the cache itself. It just you haven't like decoupled and destructured things properly, and you keep everything in one cache. And that happened many times in the practice. I've seen monoliths that try to abuse cache because that worked at some point. So those type of things by design, uh, it's important to remember that in-memory caches are not scalable, or either if you do scalability by replication, it costs a lot and very hard to maintain in my practice. So caching data is good for performance, but it should be maintained and decoupled into multiple pieces per service or per data logic. Otherwise, it will get worse than using a traditional databases for hosting your application on server side. So another tactic that I want to briefly mention, this is not that popular, but at some point you'll start using those for sure if you develop a bit scalable software, is data push tactic, where you essentially know that the rest of your application logic is going to fetch the same data multiple times. You just fetch that once and then pass that over as a request object down the line to other services, or keep in memory while other code parts is going to access that. So this tactic is not very useful for every particular case, because the amount of data that sometimes you have to fetch from the database, it's not worth passing through network to other services. But this is useful when you want, for example, the authentication request contain all the user object information for other services, so that they don't have to ask database to give them the user object directly, and they can just access that from the request context that's going to come to their end. This tactic also not very friendly of network intensive operations. So it might lead very quickly to network congestions, especially if you have high amount of load directly to the input service that essentially fetches the database. But at some point, if you have low amount of data cached within that single request, data push is way easier to implement code wise than these like Redis caching concepts. So this doesn't require that much infrastructure changes, and it's usually first step towards moving to more scalable infrastructure from the traditional or like starting point monolith. So this data push concept is easy to implement. As I said, these tactics sometimes more scalable than the traditional caches, because of course in-memory caches are not scalable. So this tactic might work sometimes a little bit better. So I usually use this tactic to deliver user authentication information across all of the services and business logic parts without worrying about like caching and invalidating. So everything keeps within the same context. That's usually easier from the coding perspective. So Netflix is one of the first companies who took a serious approach to re-architect their old Java server into a microservice architecture and heavily implement caching on the background jobs. So I wanted to bring Netflix's example because they have very good information shared about how they operate and how their infrastructure is constructed. And it's very interesting to see how they work with that large amount of numbers with so many less services. I was expecting to see more complicated infrastructure, but it's not that complicated actually. And that they also started a monolith architecture at the beginning. So this type of companies also start as a monolith and then eventually grow into microservices because it's usually inevitable. But from the beginning, like the concept of everything in one place usually works every time until some point you just can't host that much in one server or like a couple of them. So it will get very complex over time. So the main metric that Netflix used, and also it's very good approach to use, is to keep your services as atomic as possible, meaning they should not communicate with other external data sources if they don't have to, or like you can do that by caching stuff. So we are going to like very quickly to the end actually, but even if you haven't learned anything like from the rest of the presentation, I want to reiterate on the concept that programming languages are by default fast. You really don't have to worry about that part. It's the network and disk input outputs, or IO, that makes your application slow and expensive, because that's usually the most expensive parts. Sometimes I see people argue to use Golang instead Node.js or Rust for some reason to get best performance, but the difference in real world application is really negligible. When you optimize the database queries, then of course you can get like 100x better performance and more scalability. But choosing a programming language or like debating whether the programming language matters in software scalability, that's not really the case. And usually businesses approach to this say by just picking up something that really has good community support rather than better performance. That's how why Java is still the king of enterprise software at the moment. So, as a conclusion, I want to leave you with the following thought process that also like the same thing I do pretty much daily basis. Start with monolith. Over time, when you progress and your code base grow, make sure to keep services as atomic as possible and cache database queries as often as possible. And that's the main approach of like thinking how I'm going to scale my software later on, or how my Next.js server will scale down the line. That's how like the thought process should go. If you do like understand the concept of making services atomic, then that will be very easy later on to scale. So you can stay in touch with me by just taking a look on my YouTube channel or booking some call with me directly on my website if you want to chat with some topic. So I guess I'm gonna read some questions from the chat to see what's happening there. So first question actually, is chat also cached via Redis? I guess so. Those chats are usually what's happening. Like the good example is Discord. They shared at some point how their infrastructure works, and it's actually very similar how Netflix is structured. So the direct requests are actually processed through cache, and there are some database queries that have been done once. So when you, for example, open up Discord or this kind of similar chats, they don't go directly to the database to query them. They instead query cache if cache is empty, for or they haven't been any record for this particular chat channel. They query database once, store that in a cache, and then invalidate after some time, like probably every second or so. But within that second, if they receive hundreds of requests, they still serve from the cache rather than querying database more intensively. So another question, is keeping services atomic the same as using microservices? So this is yes and no. There are ways that using microservices, people are kind of decoupling stuff from there, but they still keep the communication. For example, if you have some service that have to call the authentication service every single time when it receives a request, then you don't have an atomic service, or like it could be better in a sense. So atomic means it has less dependencies, or ideally it shouldn't have dependencies, but in practical terms, you can't build an infrastructure that doesn't have a dependency. So the dependencies should be as less as possible. That's how generally you achieve better performance, because you don't have an internal network delays for querying some data or requesting API stuff. So that's the whole like concept of building this kind of like scalability in mind. Less dependencies, more caching, but like caching shouldn't be abused. So it's always a trade-off of something. Depending on the infrastructure type, you will end up compromising something. Either it's more costs for higher, bigger ROMs, or for the cache in memory cache, or less costs on that side but more intensive network requests. So in AWS there is good practices as well. By default, when you build your serverless application, they try to host everything together, like your RDS within the same network group, etc. Like those type of things help to eliminate most of the network latencies. But you still, for example, in Lambda, AWS serverless Lambda cases, you have to call RDS less often, because that will lead into network congestions on RDS side. And that's usually what happens if you try to use serverless for everything. So those kind of tactics usually work best if you think upwards how your infrastructure will be scalable down the line when you have more microservices.
Wow.
But yeah.
Interesting. That's so great to hear about. And I have, I think while everybody else is typing a question, I do have another question that I wanted to ask you. It was a great talk for sure. But we're also running a crowd themed event in parallel. And in that context, I was wondering if you have any strategies you would recommend, for optimizing software services to make use of those cloud resources. And how does it impact the overall performance? And if you had any tips on that.
Yeah, so cloud resources. The most expensive one is, of course, the memory and networking, and that could be achieved with the disposable services. I mentioned the AWS
Yeah.
Lambda serverless things,
Mhm.
which are very good ways of doing background tasks, but they are terrible in maintaining a production request response concepts because
Mhm.
essentially every single time you allocate the same memory for each request, which is not efficient. But instead, you can host long running tasks for handling a request response. But it's very good for background jobs.
Yeah. Okay. I think we have another question. We can keep talking about this on the cloud
Yeah.
computing side, but we have another question from B Codes. What are your thoughts on edge computing? That's an up and coming thing, but what are your thoughts on that?
Yeah, edge computing is actually like solving pretty much most of the issues that we have with the network congestion and
Mm-hmm.
issues with efficient caching. That's pretty much like the standard way nowadays to deploy like applications, Next.js, or any UI facing stuff. But those are not for, of course, compute intensive tasks. Usually you have to prepare your data, cache it somewhere, and then give that to the edge service to serve to the clients. But then you don't have to worry about network congestions on your cache side because edge services take care of that. Like they can handle pretty much any amount of requests. That's kind of their job to do that. And yeah, and usually they are cheap. For example, with Cloudflare, you can get started with free tier, and then
Hmm.
it's not that expensive, even though you pay stuff there after a while.
Interesting. That's amazing to hear. So with the discussion on caching and the way we can use cloud resources, and as you said with edge computing as well, we can use Cloudflare and other things. With all of these, there are definitely costs associated to it. And of course, we are working on optimizing a scalable system at this point. So, can you share some insights on how you can monitor and check the analytics for all of this? How can like have some key performance indicators that can give you an idea that okay, yes, at this point the optimization is working for you. You can measure the success of what your efforts have been put in the system.
Yeah, usually I use Datadog for
Hmm.
monitoring stuff. Like it's really good for AWS, and also they have integration with Cloudflare as well. That's really good indication. But of course, like the traditional response times of from standard logs, that
Hmm.
also will show how well you have done. And at some point, of course, Cloudflare also shares the data, how many users they served, how much traffic they gave away, and how much they could optimize. And that also helps to understand like, did you completed the job like in a way that was the most optimized way, or like you still have things to do.
Hmm.
Usually you can't end up in a place where it's fully optimized. It's like always a trade-off or something. And that's how it's done like usually. But yeah, monitoring system, that Datadog is really cool. And you can get started basically for free for like to just attach to your AWS account.
Wow, great. Thank you so much for sharing that. Datadog, right? You mentioned that's
Yes,
the
yes.
tool. Awesome, great. Yeah, lovely. Yeah, I think we have one more question about the presentation here. Uh, is there a way we can share the presentation with
Yeah,
the
I'll share presentation right after the call.
Awesome, great. Yeah, and we can share it on Discord as well, where
Mhm.
hackers are
Yeah,
participating in Month Hackathon and Global Hack Week. There are two celebrations happening this month, end of the year.
nice.
So great. Amazing. Awesome. Yes. I think while everybody else is typing in questions, I do have one more question that I wanted to ask from you, Tigran. So I hear that you have. So basically, when we started this talk, we talked about what a great experience you have, 10 years of experience in the industry, and now you're working as a CTO. Can you tell me a little bit on how you started out in tech and what your journey has been like on these in the past years?
Yeah, sure. So I started back in 2013 as a PHP backend developer. But then like I quickly switched to full stack. At that time was Angular was new and like everything was like front end became more like programming rather than styling. So that was
Mhm.
very good time. So over time, I made a couple of my projects, managed to sell one, and at some point, I just converted from being a developer to more like a consultant role. And using my open source projects, I've been consulting companies for the
Mhm.
past like 8 years. So it was a really kind of good journey in a sense that I had open source tool that was at some point one of the first networking libraries on the Rust ecosystem that gave me a bit of boost in finding a new clients and implementing projects.
Wow, that's so amazing. And when you went into consulting side, did you work on multiple projects, you worked with multiple companies, or was that something in open source that you did and mostly focused on?
No, actually, I kind of used open source as a marketing tool, so it wasn't really kind of usable directly. So you could see the results and then kind of use that from your enterprise by developing similar approach. So I was just selling an idea on how they can optimize the networking within the company, and usually it wasn't the same implementation, but the starting point was the idea that they received from the open source project, and that helped a lot for like establishing better career path and also learning different types of infrastructure. So I was exposed to large companies infrastructures that I wouldn't have known without like those type of consulting experiences.
Wow, that's amazing. And our hackers are really excited to hear this journey. You also mentioned that you are at this basically you are promoting CTO as a service, if I
Yeah.
this correctly, at blockpulsar.com. Can you share more about that?
Yeah, so back when we started, like 3 years ago, so we saw a need of non-technical founders who want to jump into these software as a service projects, and
Mm-hmm.
usually they know problems better than engineers, but they don't have enough money to hire one to be like co-founder or like pay a salary. So we jump in as like attachment of consulting company where we have resources to develop their stuff using usually no code tools or tools that are available directly without that much of expense. So we started to sell those services like which we call like CTO as a service. So we
Mm-hmm.
consult companies on and starting entrepreneurs on how they can automate their business using existing IT tools. And usually nowadays it's very common kind of to automate stuff with the AI integrations. We usually doesn't involve that much coding, but
Mm-hmm.
more knowing where to plug what.
Yeah, that makes a lot of sense. And I have not seen CTO as a service as a common business model out. And it definitely is a market for it, I believe, because I've seen there are a lot of people that I know who are in non-tech who have like great business ideas and who can definitely like go and do like basically do well in the field of tech. But the part where they lack is technical skills or knowing someone who with the right technical skills to build that stuff for them. And that definitely is a great service you're providing to a lot of folks. Okay, we have another question from Rajesh. I'm interested in building scalable and reliable web applications. Can you tell me what I should do? I currently know MERN and Next.js. Great question. What are your thoughts, Tigran?
Yeah, so if you know MERN and Next.js, essentially, you know pretty much everything. Uh, you can host your application at Cloudflare or on Vercel, Netlify. They do take care of everything, and their starting price is from free to literally like 10 or 16 dollars a month. So it's quite cheap, and you will get like pretty much all the scalability things that you want. And usually that's not the issue. If you grow a bit, like having more background job processing or large video image uploads, then you might want to learn more things like Kafka, that you can schedule jobs to for background processing, or AWS serverless for having more scalability on your concurrent job processing. So those types of things will come, like I'll say, naturally down the line, but you basically have everything you need from starting point right now. Next.js is great. You can just forget about scaling your services with Next.js. It pretty much works all the time. You can just host it in Cloudflare, Vercel, and forget about like whether my application will be down, or like am I gonna be available for some regions, etc. Like Cloudflare or Vercel or like Netlify. They will take care of everything. They have pretty much all the tools built for specifically that use cases.
Interesting. Another tip that I remember when I was a student was that a lot of these cloud services had student run programs where you can get credits and then get started easily. So, a lot of these tools that you mentioned, I remember as a student, there were credits available for that could get me started with like a single project. And then from there, if I wanted to grow, then I can opt in for the service that I need.
Yes, yes. And I really love Cloudflare because they offer from the beginning, like pretty much everything is free. And
Mhm.
then at some point, when you hit the scale, they start to charge, which is like completely normal. Uh,
Yeah.
uh, like one of my products, like here, Alin.io, which is a private package registry for Python, Docker, and NPM. Even
Mhm.
though I have active 1,000 users using, like I still on a Cloudflare free plan. Of course, I
Ah,
use servers to host rest of the background job processing that happening, but the actual Next.js application is on a Cloudflare free plan. And that's what like amazing with this type of tools. Like they are very cheap to operate, and nowadays like you can find any place basically to host those.
yes. And I believe that there is great documentation to get started with these tools as well. So, if you're a student, if
Yes,
you're trying this for the first time, like don't worry, there is great documentation that you can do the step by step and then get your system up and running.
yes, and Next.js is great in that sense as well. That they have very good community. It's
Mhm.
pretty much the most popular like UI framework, or like full stack framework, I will say, for building web apps at the moment. And you'll find pretty much anything there. And usually deployments are working by default.
Awesome, great. All right, we have another question from VCodes. How do I sign up to be a provider for CTO as a service? Great question. What are your thoughts, Tigran?
Yeah, so I'll say like selling these type of services are not easy. It just involves a lot of networking and connections. Pretty much all the uh, communication we are doing is direct, so there is no advertisement per se to just kind of advertise stuff on Facebook and get clients.
Mhm.
These type of things are just personal connection, so you have to go to events, conferences, so those type of things, like just talking with the people making sure that they trust you, because that involves a lot of trust to like just getting a service to be in a role of the CTO.
Yeah, definitely. Makes a lot of sense. I have another question from Shraddha. Could you please share how I can plan a wireframe, etc., a project, since I've never really created a complete software project before, although I'm trying to do so now? What are your tips?
Yeah, so wireframing, usually I use Balsamic. It's a desktop application. They also have a cloud version as well. It's very good for like overall planning and understanding how your UI and functionality will work. But other than that, pretty much all other tools like Figma or Miro will work for wireframing. And yeah, I guess. And the tactic there is that usually I sketch out with the Balsamic or Miro, I sketch out the UI,
Mm-hmm.
how the functionality is going to work. Then I imagine what should I need for the API to kind of be usable for that designed UI, because like UI pretty much the most important thing that users see from the perspective of IT product.
Interesting. We have another question on from Rajesh. Don't you think rendering front end, example HTML and CSS, on server increases load on the server and ultimately increases the cost?
So that's very interesting thing. Back then, when there were technologies like a PHP standard rendering things, so server have been doing the same as you described. So PHP have been rendering to HTML, CSS, and then serving to the browser. But that was more costly actually than the practice that we have here with the server side rendering. The concept's a bit different because with, for example, Next.js server side rendering, they cache a lot of stuff. Compared that to PHP, where there were no caching on the end result of the rendering. Next.js actually caches, and pretty much like similar frameworks uh, like Nuxt.js, like they are work the same way. The server side rendering nowadays, they render once and then serve that cached result with the JSON data embedded in it for like some time, unless they detect that JSON data or React DOM have been changed on a server side. So that's why those type of frameworks nowadays are very cheap to operate compared to older monolith structures that PHPs have been doing. And of course, server side renderings are, I would say, the most important thing if you have public facing web apps, because you want SEO, you want faster response render times, and faster to interactive times for the user that you can't receive with the traditional like one page React applications. But of course, one page React applications are good for having something like admin panels or things that, I don't know, you don't care about SEO and you don't need to have HTML available directly when user visits your website. But like to answer your question, now it's with current tools, it's actually cheaper to render HTML using server side rendering, because those services or like frameworks built in a way that they cache pretty much like 90% of things and then re-render when there is data change.
Awesome, amazing. I do have another question on the same. Not in terms of cost, but at the beginning of this presentation, I remember you mentioned how when you're starting out, it's great to build like a monolithic code architecture, and then as you grow, consider those considering services as an atomic service as much as possible, and then going from there. So, do you have resources that we can refer to about growing from a monolithic structure to a complex structure like that? Some books or resources that you follow as well for learning these concepts?
Yeah, usually I read the big company blogs. So that's
Uh-huh.
a very good resource because sometimes, for example, Netflix uh, uh, did this re-architecture of their from monolith to microservices. I
Mhm.
guess 4 years ago or 5 years ago, and I remember reading that from their technical blog and uh, getting an idea of what's gonna happen in that kind of scale, because the scale of Netflix, you really, I don't know, you can't understand that unless you really worked with those type of things, and you
Mhm.
really can't plan your infrastructure to meet that scale until you got there. So it's really interesting to kind of read those technical rewrites. Facebook also does that. Google also does that. Like, for example, if 2 days ago Google published their, let's say, this new
Yeah.
Gemini AI
Right.
model,
Mhm.
where they technically explain how infrastructure works as well underneath with
Yeah.
this multimodal structure. That also like will give you really good sense on what's going to happen if you have this type of like very compute intensive resources, and how you can deploy them to operate at this kind of scale. But those type of resources are just kind of giving you an idea, but your specific case usually different, because you
Mhm.
don't have first their scale, and second their operation costs are different than yours. For
Mhm.
example, in our projects we try to optimize so that we'll have more run rate, but for example, the company that I've been doing consulting last year, they told me that we have pretty much unlimited infrastructure budget, just do
Mhm.
something to get our response times lower. So it's like varies a lot, and
Mhm.
techniques will be very different. At some point, you will just start compromising stuff. But yeah, from the resources, reading tech blogs and reading the Hacker News, because they also publish a lot of good stuff there from time to time related to infrastructure. But that's like my main topic. I usually don't trust that much books in these type of situations, because each company has its unique cases, and this type of software paradigms shift so fast that
Yeah.
like if you read a book like now, after 3 4 months, like it will be completely different.
Makes sense. Yes, definitely. And I'm glad that you mentioned about Netflix as well, because I was looking at the Netflix, I think a blog that they recently shared about their AWS billing services as well. And it was a great read because they talk all like they talk about those things in detail, and then it gives you a code pointer on like, okay, this is something that you can refer to, learn more about this, and then think about things that work for you in your case that can help you out.
Yeah.
Awesome. Great. I think that is it in terms of questions, but definitely if you have some more questions, we are here for a few more minutes. Feel free to post them in. But okay. Yeah, I think it's once you share the presentation link with me, I can also share it with the hackers as well. That is one outstanding question that we have had. Awesome. All right. Yes, there's some uh people like learned a lot from the Q&A itself. It's great to
Nice.
hear. Thank you so much for the amazing session.
Yeah, thanks. And the good reads, of course, like look up at big companies like tech blogs. That will help a lot. At least I've been learning most of the stuff from them.
Amazing. Yes. And if you want to learn more about Tigran and his journey, you can follow the links up on screen. There, the slide is still up live. So you can follow him on this YouTube channel, and there's tigran.tech, which you can refer to. We also have a month-long hackathon running. So if you want to learn more about all of the stuff, you can continue and participate there, build software projects. There's a lot of resources that we discussed in this presentation and Q&A. And if you want to refer to those for your projects, it would be a great way to just get started. You know, experiment some stuff out and then see what works for you. Awesome. Thank you so much for joining, everyone. Thank you so much, Tigran, for taking time
Thank you.
out and sharing your tips with us. It's been great to chat with you. We definitely learned a lot. And yeah, have a great day. Happy hacking, everyone.
Sure. Bye bye. Thanks for having me.